Okay, so we're on Journal 8 here, and I want to talk a little bit about absolute values today with you. So we talked about absolute values, you might have remembered, in the previous week. We talked about how when you have the absolute value of something and it equals some number, then we have to consider that x equals that positive number, but also that x equals that negative value. So it's like the same thing here. If we have an absolute value and if there's those inequality signs, well, we have to consider that that could have been a positive a and a negative a. But here's the thing. Depending on the inequality sign and how it faces the absolute value, then the situation will change. And I'll show you guys that here. So the first one we're going to look at is when absolute value inequality is greater than. So let's take a look at the next slide. Okay, so what I want you to notice with this one here is that this inequality is facing towards the absolute value. That means that mouth is open towards the absolute value. So whenever it's towards, it is going to be two equations because we have to consider that the absolute value was greater than positive 3 or the absolute value of x, so x, is also could have been negative 3, but because we switched that sign from a positive to a negative, we also have to switch that inequality signs. So the inequality sign actually flips too. And so now we have two equations. So every time it faces towards the inequality, you actually have two separate equations. So two equations is what I'm talking about, two separate equations. And that's it. So whenever you see this absolute value, you can break it up like these two separate equations. And all right, let's try some example problems. Okay, so in this example here, I have an absolute value, and notice that this inequality is facing towards. I'm going to write that here. It is facing towards the absolute value sign. So that means I know I have to split it up into two equations. So it can be 2x plus 1 is greater than positive 7, or 2x plus 1 is less than or equal to negative 7. So from here, I'm going to try to get the x by itself. So maybe I want to move that 1 over first so I can start getting the x by itself. So that cancels. So we have 2x is greater than 7 minus 1 is 6. Divide that by 2. X is greater than or equal to 3. And so there we have it. X is by itself, so we have the first equation. I'm going to do the same thing on this side. If I subtract the 1 over, 2x is less than negative 7 minus 1 is negative 8. If I divide that by 2, x is less than negative 4. So x can be either greater than 3 or less than negative 4, and I'll highlight that in for us. Let's do that in green. Okay, so now that we've gotten a feel of this, I want us to look at problems from the homework packet, page 3. So turn to page 3 and try out problems 2 and 5. I'm going to try those problems here in this section. Feel free to write this on your packet, not in your journal. So I'm going to pinch this a little bit, maybe make it smaller. Yeah, put this to the side. So I'm going to write 2 here, number 2. So if you turn to page 3 on the packet, I believe the problem is 2h plus 5 absolute value is greater than 10. So it will say to solve this problem, just to solve for the inequality. And so that just means that you just need to get the variable by itself. So that's what we're going to do here. So if I want to solve for this inequality, I need to divide by 2 because the absolute value is not by itself, right? We always try to get the absolute value by itself first. So then the 2's cancel. And so then I have h plus 5 is greater than 5. And then I would break these up here. H plus 5 is greater than 5, or h plus 5 is less than negative 5. So from here, I'm going to subtract 5 to get the h by itself. So h is greater than 0, or if I subtract 5 here, h is less than negative 10, and so h is by itself, so I am done. This is my answer for number 2, and it just says to solve for the inequality, and I did. I have the variable by itself. Number 3, number 5 on the page 3 is a little bit different. It wants you to solve for the inequality, but it also wants it in interval form, so don't forget those parentheses and brackets. So I'm going to move this to the side. So I'm going to bring in number 5. So number 5 here is the absolute value of y plus 5 is greater than 2. So I'm going to break this up because the absolute value is already by itself and it's facing towards the absolute value, so I know that it is 2 equations when it's towards. And so I have y plus 5 is greater than 2, or y plus 5 is less than or equal to negative 2. When we subtract by 5 on this side to get the y by itself, we get y is greater than negative 3, or when we subtract 5 on this side, y is less than negative 7. So this here is our inequality solved because the y is by itself. But it also wants the interval notation. So it wants the, that's a highlighter. Interval notation. So if I want the interval notation, I need to do it in brackets to parentheses. Now we learned if you have a hard time figuring out what the interval notation is, all you got to do is draw yourself a simple line graph. So we're going to plot in our two numbers. We have negative 3 and negative 7. Now negative 7 is more negative, so it's actually going to be on our left side here. And then we have negative 3. We need closed circles. Okay. Now, this one says for negative 3, y is greater than negative 3, right? So in this case, if y is greater, it needs to be shading that way. And so in this case, this is going to be going to positive infinity. What am I saying? All right, and then this side here says y is less than negative 7. So that means I need to be shading on the left side because these are numbers that are less than 7. And that would be negative infinity. So if we're going from negative infinity, so parentheses to negative 7 for this section, and then for this section, oh, I think I need a bracket, don't I? Yeah, let me fix that real quick. So we need a bracket on the 7, union, bracket on the 3 to positive infinity. And there we have our interval notation. Okay, so now let's take a look at what we would do if the inequality here was facing away. So instead of facing towards the absolute value, it's going to face the opposite direction. And we're going to see how we can handle that situation. Okay, so whenever it's facing away, it's a little bit different. So I want us to first treat this problem like we did before. So absolute values mean that there's a negative and there's a positive. So we're going to work it out like we did before. So a negative, the positive would just be x is less than 3. And then if we were to find the negative, well then we have to switch that sign, right? So that way we can write it as a negative. Now, before you leave your inequality like this, I want us to look at the line graph because you will notice something special about these two separate equations. They're actually not too separate. So if you were to graph this, negative 3 comes first, then positive 3, closed circle because this has an equal sign, right? There's an equal sign. And so if you look at the negative 3 one, right? So this here says x is greater than negative 3. So if x is greater, you want to be shading this way. So to the right. If you were to shade to the right, and keep going, you will hit the 3. And you will be asking yourselves like, well, can I pass 3? Well, before you try to answer that question, you better look at what the inequality says for 3. So it says x is less than 3. So nope, you can't pass it. Instead, if you were to look at this one, it says because x is less than 3, you would have to shade the other direction, right? You would shade to the left, but then you can't pass this negative 3 because it says x is bigger than negative 3. Well, that means that the x is between negative 3 and 3. Well, isn't that the same inequality as saying negative 3 goes x, and then x is less than positive 3. So x is greater than negative 3, but smaller than 3. So what I'm saying is that instead of writing this as two separate equations, you actually have one equation where all the inequalities are facing one direction, and they're usually facing that positive 3. And actually, they should always be facing the biggest number, in this case, 3. So in conclusion, you don't have to write your equation as two separate equations. You can write it as one equations with two inequalities, and they should all be facing one direction. So we're going to do some practice problem using this idea, and then we're going to do some problems from the packet. Okay, so here is an example where the inequality is facing away from the absolute value sign. So if it's facing away, remember, we can write it as one equation, and how you do this is you basically copy this equation without the absolute value signs. So that would just be 2x plus 1 is less than 7. But then on the left side here, you're going to add in that negative 7, and they should all be facing, the inequality should all be facing the same direction. So it should be facing the bigger number, which is the 7. From there, we're going to solve and try to get that x by itself. So we need to subtract 1. So if you're subtracting by 1, remember, you have to subtract it from both sides. So subtract 1 on both sides. That cancels, so we have 2x. 7 minus 1 is 6. Negative 7 minus 1 is negative 8. If I divide by 2, six divided by 2 gives me 3. Negative 8 divided by 2 gives me negative 4. And so then x here is between negative 4 and 3. And that you would leave your answer like this because it's just asking you to solve. So we're going to do another problem like this from the homework packet. So same page, page 3. We're going to look at number 4 together. This one you might need to bring a calculator with you or grab your phone calculator, whatever you need. So I'm going to bring this up a little bit. There we go. So this is number 4 here. These are really big numbers, so that's why I suggest you bring out a calculator. So looking at this problem here, we're going to try to first get this absolute value by itself. So I need to move over the 9 first because it's further away from the absolute value. So I'm going to subtract 9. And so I have 5, 3w plus 1. Plus 11 is less than 136 minus 19 is 170, I believe. And then if you divide by 5 to get rid of this 5, you have to divide it on the other side. So this is where you might want to bring in your calculator. So if you divide 107 divided by 5, I believe it is 23.4. And then from here, the absolute value sign is by itself. So that's when you can start, including your negative value here. So because this here is facing away, right? This is away, the absolute value sign. So this inequality is facing away. That means we have one equation. So we can write this as 3w plus 11 is less than 23.4, and also negative 23.4. Let me make some more space here. Okay, so from here, we're going to just try to get that W by itself. So I need to move over the 11 first. So subtract 11. So we have 3W. 23.4 minus 11 is 12.4. And then 23.4 minus 11 on this side is going to be negative 34.4. If I divide by 3, that means 12.4 divided by 3. I'm going to round to 2 decimal places. So this would be 4.13, and this side here would be 11, negative 11.47. And then I'm just going to highlight that here, and I am finished because I have the W by itself. Okay, that was quite a bit. So on this space here, I'm going to do number 7 for you guys. That one, we do have to write it in interval notation. Number 4, we don't. But for number 7 here, you have the absolute value of x, 2x plus 2 minus 7 is less than or equal to negative 5. Okay, so first things first, you got to get that absolute value by itself. So I have to move over that 7. So that cancels. So this is really a positive 2 on this side. So from here, we're going to take a look at this absolute value sign. This here is facing away. So away means we have one equation. So I'm going to write it as 2x plus 2 is less than 2. And then on this side, I'm going to add in that negative 2. And all the inequalities are facing towards the right, towards that positive number. Okay, so from here, we're going to try to get the x by itself. So subtract 2 for both sides. This side would be 0. 2 minus 2 is 0. This side here would be negative 4. If I divide this by 2, then this side would still be 0, right? 0 divided by 2 is 0. You have an x, bring it down, and then negative 4 divided by 2 is negative 2. And so now we have this inequality that is x is between negative 2 and 0, right? But we're not done here because we need the interval notation. So to do the interval notation here, we're going to make a small line graph, but we're going from negative 2 to 0, and they're both closed circles. And so x is between these two numbers, so it is going to be in this region, right, in the middle. So I have a bracket on the 2, the negative 2, and a bracket on the 0. And that's it. That would be my interval notation. Okay, so hopefully that helps you out with the homework. Let's summarize here what we've learned. Okay, to kind of put everything in a nice nutshell here, we've learned 3 different types of absolute values. We've learned that with equal signs, so equal signs is when x can be equal to a or x can be equal to negative a. Basically, you have to split it into 2 equations. Then for this one here, when a is, or actually the inequality is facing away, so the inequality, let me do that in pink. So if it's facing away, that means you have one equation. So you'll notice that it is the same inequality without the absolute value sign. So positive a, but then on the tail end or the left side, you'll have the negative a. And all the inequalities are facing one direction. It's facing the positive value. And then you have the last one here where the inequality is facing towards the absolute value. And so in this case, this is going to be 2 equation. And like I said, I like to remember this because they're both t's. So towards means 2 separate equations. So in this case, you're going to write it as x is greater than a, almost like how it's written here, just without the absolute value signs. Or x can be less than a, less than negative a, because you had to flip the sign to when you change it to a negative value. And that's it, guys. That is your Journal 8, all about those inequality absolute value functions. All right, have a great day, guys.